Hi everyone and welcome to this video. This is the first video in my series that aims to help actuarial students who are preparing for the financial mathematics exam. Now the key to passing this exam is practicing a good variety of past exam questions. Today's question was hand selected since it covers a broad range of concepts and was generally quite poorly answered by students. This is the question we're going to be looking at today. The question asks us to evaluate the price of a share for a given dividend payment stream. Recall that the price of a share is just the sum of the present value of the future dividend payments. Our job is to transcribe this rather wordy description of the cash flows into a mathematical equation. The first thing we'll do is to create a timeline representation of the word problem. Now this timeline effectively collapses the word problem into a picture that is much easier for our brains to deal with. A proper timeline is the secret sauce to solving most of the application type questions you will encounter in this exam. We are told that the first dividend payment will be made in 2 years' time. So we'll place the first dividend payment at time 2. Now the value is given and that is 20 US cents per share. Using this particular value is going to clutter my timeline, so I'm going to use the symbol D to represent the first dividend payment, just to keep things neat on the timeline. We also know that subsequent annual dividends are assumed to grow at 6% per annum or per year compound for the following 10 years and then 3% per annum compound in perpetuity thereafter. So from this information, we know that the next dividend payment will be made at time 3 since the dividends are declared annually. We also know what the amount will be. It will equal the previous dividend payment plus 6% or D times 1.06. So from this information, we know that the dividend at time 4 will equal the dividend at time 3 multiplied by 1.06. If we substitute for D3, we know that this is just our initial dividend multiplied by 1.06. And so the value for D4 will be D3 multiplied by 1.06, which is just D times 1.06 squared. We can now add this to our timeline. This pattern will continue for 10 years, after which the growth rate will change from 6% to 3%. Whenever there's a change in cash flow pattern, you want to plot the cash flows just before and just after the change on your timeline. We know that the growth of 6% will apply for the next 10 years. So we need to figure out when the final payment will be made and what the exponent of that final payment will be. I find the easiest method to keep track of this is to use an index. So the first year of growth will be at time 3, which means that the second year of growth will be at time 4. So we are interested to know where the 10th year of growth should go on this timeline. So we want to calculate the value of t, and we're also interested in the value of the cash flow, which will be of the form d times 1.06 to the power n. When you use the index method, it's fairly simple to see how you get from an index to a year. Let's look at the third year as an example. You can see that if we add 2 to the index value, we obtain the year number 3. And by the same token, if we take the second index and we add 2, we obtain the year number. So now we know that t is equal to the index plus 2. So we use the formula to figure out t, and that is equal to the index value, which is just 10 plus 2, which is 12. So we know that this dividend payment occurs at time 12. Next, we need to find the value of n, the exponent, so how many years of growth should we add? This is quite obviously equal to 10 because we are dealing with 10 years of growth. If you want to make 100% sure, just compare the index to the exponent for the first 2 years and you will see that they are exactly equal. You can certainly use other methods to track the size and the timing of cash flows. However, in my experience, this is often when things go wrong, so ensure that you check yourself. So let's plot the remaining dividend payments. We know that after the first 10 years, dividends grow at 3% per annum compound in perpetuity. So the dividend at time 13 would be the dividend at time 12, which is d times 1.06 to the power 10 multiplied by 1.03. So by now you should be able to work this out quite easily. The dividend that you receive at time 14 includes the 6% growth for 10 years as well as growth of 3% for 2 years. Remember, these payments continue in perpetuity. A good timeline is a key component to solving these types of questions. Well done if you understand this and you've gotten to this point. It's a big step in the process, putting this wordy problem into a timeline, and that enables us to write the equations. So very key part of solving these types of problems.